Part I. Solve between 0 and 180 degrees the equation sine 2 theta divided by 4 sine 2 theta minus 1 is equal to 1, giving answers to 1 decimal place. So first thing I'm going to do is multiply both sides by the 4 sine 2 theta minus 1. So that's going to give me, I'll still have the sine 2 theta on the left hand side, and on the right hand side I've got the 1 times 4 sine 2 theta minus 1. I am then going to add 1 to both sides, so I'll get sine 2 theta equals plus 1 equals 4 sine 2 theta. Take the sine 2 theta away from both sides, divide both sides by 3, and now I've got to the point where I can do sine inverse. So when I put that into my calculator, notice that we are in degrees in this case, so make sure your calculator is in degrees mode. We will get 19.47. Now, we now need to draw the graph. It's at this stage, remember, that we draw the graph to find the other solutions. So just a quick little sketch. Doesn't have to be particularly accurate, just in the right places. So we're going 90, 180. Now I know the question says to go up to 180, but I'm actually going to go up to 360 because I know that in a minute I'm going to be dividing by 2. So let's find the answers that are 2 times bigger than what we need, because we'll divide them by 2 in a minute. Right, 1/3 is here. So we've got one solution here, we've got another solution here. So this is the 19.47. So then this would also be 19.47. So if I do 180, subtract 19.47, I'll get 160.528. So these are two answers that are between two answers that can give me 2 theta. I'm now going to divide both of those by 2, and I'll get 9.7 or 80.3. And those are my 2 answers for theta. Part II. Solve between 0 and 2 pi the equation 5 sine squared x minus 2 cos x minus 5 is equal to 0. Right, so I am going to change the squared function so that it matches the linear function. Remember, we're always changing the squared one so that it matches the linear one. I know that sine squared is the same thing as 1 minus cos squared. Oops, that should be x, not theta. There we go. So I've got 5 lots of 1 minus cos squared x minus 2 cos x minus 5 equals to 0. Expand the brackets. And write this in our usual quadratic form. In fact, actually, before I do that, just noticing those 2 5s cancel out. So we will get 5 cos squared plus 2 cos x equals 0. So all I've done there, cancelled the 5s out and multiplied both sides by -1. At this stage, I can factorise the cos x outside because we have a cos x in both of those terms. And now I can see that either cos x equals 0 or cos x equals minus 2/5. If I do cos inverse now, so cos inverse of 0 is Well, my calculator tells me pi over 2. We're in radians, so make sure your calculator is in radians mode. Let me draw a quick cos graph to make sure that we get all of the correct solutions. I'm drawing my cos graph with radians now, so we're going up in pi over 2s. And the cos graph looks like this. So the first solution, when it equaled 0, was here at pi over 2. The second solution we can see is here at 3 pi over 2. From the second bracket, if I do cos inverse of minus 2/5, then I get 1.98 radians as my first solution. The minus 2/5 is roughly here. So my 1.98 is about here. I'd have another solution here. Like I say, this is 1.98. So this will be 1.98. So to get this answer here, I need to do 2 pi minus 1.98, which gives me 4.71. So let me just double check that. 2 pi minus 1.98. I thought that looked a bit funny. That should have been 4.30 radians. And these are the 4 answers to that equation.